Welcome to Lesson 3, friends. In this one, we're going to talk about reading multiple limits from one graph. So look at this picture. There's a lot going on here. So let's decipher it. First is focus on the piece all the way on the right side. Take a look. I'm going to draw an arrow that goes along the x-axis and then approaches 2 from the right side of 2. Look very carefully there. Notice when I do that, essentially points would be moving along this piece of the graph right here. The y-coordinates of those points are moving towards 4. So you should draw an arrow along the vertical axis that suggests that you're approaching 4 from below. Right there, you see? What does that allow us then to say? What we can say is this. The limit as x approaches 2, and because I'm approaching from the right side, I'm going to say the following. I'm going to put up there with the 2 a little plus. And I'm going to say here f of x. I don't have an expression that represents the function, so I'm just going to call this whole thing f of x. And then here in this case, for this one, it's just equal to 4, as you see with the black arrows. Take a look at the next stage in the process. I'm going to use red arrows. When I approach down below on the horizontal axis, 2 from the left side, the points move along this green piece of the curve right there, and they're moving towards that hole, which means that the y-coordinates are moving towards 3 from below 3, right here, you see? What can I say mathematically to describe what the red arrows are suggesting? What I can say is that the limit as x approaches 2 from the left side. So notice with the 2 now I'm putting a little negative there. And then here I put f of x, and that is equal to positive 3. Whenever you have something like this happen, where the limit from the left and right are different in value, then this suggests that the overall limit does not exist. In other words, I can suggest the following here. That the limit as x approaches 2, and notice when I write this version of it, there's not a plus or minus up there. This is just called the overall limit. The limit as x approaches 2 of f of x here does not exist. In other words, for an overall limit like this one here to exist, the left and right hand limits have to be equal in value. We do not have that here. Let's look at the next stage, friends. What happens if x approaches 1 positive from the right side? Then this would move down this way, which means that the y-coordinates would move down towards positive 2, but from above positive 2. So first what I would say is the following. The limit as x approaches here 1 from the right side, so put a little positive up there with the 1, of f of x, that's equal here to 2. Take a look at the next stage. When I approach positive 1 from the left side, then you see the points would move along this branch of the graph. But if you image that over to the y-axis, it would still look like the following. You see, they would still be moving towards positive 2 from above. So look very carefully. There are 2 green arrows there. Look carefully. So what I can say then is the following. Take a look. I can say that the limit as x approaches here 1 from the left side, so put a little negative up there, of f of x is equal to positive 2. When you have this occur, in other words, when the left and right hand limits are the same, what we can conclude is the following then. That the overall limit as x approaches 2, no more plus or minus up there, of f of x exists and its value is equal to 2. The fact that right here at the point 1 comma 2 the function is not defined, again, going back to the previous lesson, not relevant for limits. One last case here. I'm going to grab a different color for the arrows. Look what happens when I approach negative 1 from the right side. When I do that, the values of the function will be sliding up that part of the curve, which means that the corresponding y-coordinates would be going this way, basically towards positive infinity. So what this then says is the following, that the limit as x approaches negative 1 of f of x, but you have to say it's from the right side, so put a little positive up there, and then of f of x, that's equal to positive infinity. That's a way of expressing it. Take a look on the other side. When I approach negative 1 from the left side, then the points would move along the graph this way, and that means that the y-coordinates would move down this way towards negative infinity. So what I can say is then that the limit as x approaches here negative 1 from the left side, so put a little negative up there, of f of x is equal to negative infinity. Clearly you can tell you have two different infinities. There's no way to reconcile them. So we would say as a result is the following, right here, that the limit as x approaches -1, no more plus or minus with the 1, just -1, of f of x is the same as before. Does not exist. Let me move this into position so it fits better. And that's a wrap up on this lesson. Thank you so much for watching. I'll see you in the next lesson.